In photography and videography, a filter is a camera accessory consisting of an optical filter that can be inserted in the optical path. The filter can be a square or oblong shape mounted in a holder accessory, or, more commonly, a glass or plastic disc with a metal or plastic ring frame, which can be screwed in front of or clipped onto the lens. Filters modify the images recorded. Sometimes they are used to make only subtle changes to images. Other times the image would simply not be possible without them. In monochrome photography, colored filters affect the relative brightness of different colors. Red lipstick may be rendered as anything from almost white to almost black with different filters. Others change the color balance of images, so that photographs under incandescent lighting show colors as they are perceived, rather than with a reddish tinge. There are filters that distort the image in a desired way, diffusing an otherwise sharp image, adding a starry effect, etc. Supplementary close-up lenses may be classified as filters. Linear and circular polarizing filters reduce oblique reflections from non-metallic surfaces. Many filters absorb part of the light available, necessitating longer exposure. As the filter is in the optical path, any imperfections are non-flat or non-parallel surfaces, reflections, scratches, dirt affect the image. There is no universal standard naming system for filters. The Rattan numbers adopted in the early 20th century by Kodak, then a dominant force in film photography, are used by several manufacturers. Color correction filters are often identified by a code of the form CC50R CC for color correction, 50 for the strength of the filter, Y for yellow. Optical filters are used in various areas of science, including in particular astronomy. They are essentially the same as photographic filters, but in practice often need far more accurately controlled optical properties and precisely defined transmission curves than filters exclusively for photographic use. Photographic filters sell in larger quantities at correspondingly lower prices than many laboratory filters. The article on optical filters has material relevant to photographic filters. In digital photography, the majority of filters used with film cameras have been rendered redundant by digital filters applied either in camera or during post-processing. Exceptions include the ultraviolet ultra typically used to protect the front surface of the lens, the neutral density filter, the polarizing filter and the infrared filter. The neutral density filter permits effects requiring wide apertures or long exposures to be applied to brightly lit scenes, while the graduated neutral density filter is useful in situations where the scene's dynamic range exceeds the capability of the sensor. Not using optical filters in front of the lens has the advantage of avoiding the reduction of image quality caused by the presence of an extra optical element in the light path and may be necessary to avoid vignetting when using wide-angle lenses. Uses of filters in photography. Filters in photography can be classified according to their use: clear and ultraviolet, color correction, color conversion, color separation, also called color subtraction, contrast enhancement, infrared, neutral density, including the graduated neutral density filter and solar filter, polarizing, special effects of various kinds, including graduated color, called color grads, cross-screen and star diffractors, diffusion and contrast reduction, spot, close-up or macro diopters, and split diopters or split focus. Clear and ultraviolet. Clear filters, also known as window glass filters or optical flats, are transparent, and perform no filtering of incoming light. The only use of a clear filter is to protect the front of a lens. UV filters are used to reduce haziness created by ultraviolet light, to which photographic film and sensors are sensitive, but not the human eye. A UV filter passes all or most of the visual spectrum, and blocks ultraviolet radiation. It can be left on the lens for nearly all shots. UV filters are often used mainly for lens protection in the same way as clear filters. A strong UV filter, such as a Haze 2A or UV17, cuts off some visible light in the violet part of the spectrum, and has a pale yellow color. These strong filters are more effective at cutting haze, and can reduce purple fringing in digital cameras. Strong UV filters are also sometimes used for warming color photos taken in shade with daylight type film. While in certain cases, such as harsh environments, a protection filter may be necessary. There are also downsides to this practice. Arguments for the use of protection filters include, if the lens is dropped, the filter may well suffer scratches or breakage instead of the front lens element. The filter can be cleaned frequently without damage to the lens surface or coatings. A filter scratched by cleaning is much less expensive to replace than a lens. If there is blowing sound, the filter may protect the lens from abrasion from sand. A few lenses, such as some of Canon's L-series lenses, require the use of a filter to complete the weather sealing. Arguments against their use include, adding another element degrades image quality due to aberration caused by less than perfect flatness and parallelism of surfaces, and some unavoidable flare due to reflections at additional air glass interfaces. Low-quality filters may cause problems with autofocus. It may sometimes prevent the use of lens hoods that screw into the lens, since threading a lens hood on top of the clear filter might cause vignetting on some lenses, and since not all clear filters mechanically allow a hood to be attached. There is a wide variance in the spectral UV blocking by filters described as ultraviolet. Color conversion. Appropriate color conversion filters are used to compensate for the effects of lighting not balanced for the film stock's rated color temperature. For example, the ATA blue filter used with film for daylight use corrects the perceived orange-reddish cast of incandescent photographic photofluid lighting, and significantly improves the stronger cast produced by lower temperature household incandescent lighting, while the 85B will correct the bluish cast of daylight photographs on tungsten film. Color correction filters are identified by non-standardized numbers which vary from manufacturer to manufacturer. The need for these filters has been greatly reduced by the widespread adoption of digital photography, since color balance may be corrected with camera settings as the image is captured, or by software manipulation afterwards. Color conversion filters must be distinguished from color correction filters, which filter out a particular color cast FE caused by Schwarzschild effect etc. Color subtraction. Color subtraction filters work by absorbing certain colors of light, letting the remaining colors through. They can be used to demonstrate the primary colors that make up an image. They are perhaps most frequently used in the printing industry for color separations, and again, use has diminished as digital solutions have become more advanced and abundant. Contrast enhancement. Colored filters are commonly used in black and white photography to alter the effect of different colors in the scene, changing contrast recorded in black and white of the different colors. For example, a yellow or, more dramatically, orange or red, filter will enhance the contrast between clouds and sky by darkening the blue sky. A deep green filter will also darken the sky, and additionally lighten green foliage, making it stand out against the sky. A blue filter mimics the effect of older orthochromatic film, or even older film sensitive only to blue light, rendering blue as light and red and green as dark, showing blue skies as overcast with no contrast between sky and clouds, darkening blonde hair, making blue eyes nearly white and red lips nearly black. Diffusion filters reduce contrast in addition to softening resolution. Polarizer. A polarizing filter, used for both color and black and white photography, is colorless and does not affect color balance, but filters out light with a particular direction of polarization. This reduces oblique reflections from non-metallic surfaces, can darken the sky in color photography, and can saturate the image more by eliminating unwanted reflections. Linear polarizing filters, while effective, can interfere with metering and autofocus mechanisms when mirrors or beam splitters are in the light path, as in the digital single-lens reflex camera. A circular polarizer is also effective, and does not affect metering or autofocus. Neutral density. A neutral density filter is a filter of uniform density which attenuates light of all colors equally. It is used to allow a longer exposure or larger aperture than otherwise required for correct exposure in the prevailing light conditions, without changing the tonal balance of the photograph. A graduated neutral density filter is a neutral density filter with different attenuation at different points, typically clear in one half shading into a higher density in the other. It can be used, for example, to photograph a scene with part in deep shadow and part brightly lit, where otherwise either the shadows would have no detail or the highlights would be burnt out. Cross-screen. A cross-screen filter, also known as a star filter, creates a star pattern, in which lines radiate outward from bright objects. The star pattern is generated by a very fine diffraction grating embedded in the filter, or sometimes by the use of prisms in the filter. The number of stars varies by the construction of the filter, as does the number of points each star has. Diffusion. A diffusion filter softens subjects and generates a dreamy haze. This is most often used for portraits. It also has the effect of reducing contrast, and the filters are designed, labeled, sold, and used for that purpose too. There are many ways of accomplishing this effect, and thus filters from different manufacturers vary significantly. The two primary approaches are to use some form of grid or netting in the filter, or to use something which is transparent but not optically sharp. Both effects can be achieved in software, which can in principle provide a very precise degree of control of the level of effect, however the look may be noticeably different. If there is too much contrast in a scene, the dynamic range of the digital image sensor or film may be exceeded, which post-processing cannot compensate for, so contrast reduction at the time of image capture may be called for. Transparent diffusion. Zeiss manufactures a widely noted softer diffusion filter which is made of many tiny globs of acrylic deposited on one surface which act as microlenses to diffuse the light. In some versions the globs are on the inside of the filter while on others they face outwards. In various versions the globs vary in number and diameter, from approximately 97 to 150 globs each 1 mm to 3 mm wide. Homebrew approaches to transparent diffusion filters are generally based on modifying a clear or UV filter by placing various materials on it. The most popular choices are petroleum jelly, optical cement, plastic food wrap, and nail polish. Transparent filters are more commonly used for the dreamy, or misty effect than for contrast reduction. Grid or netting, various widths, colors, and grid shapes and spacings of netting, usually made from nylon, are used to provide diffusion effects. These are used both for the dreamy look and for contrast reduction. The homebrew approach to this sort of effect is generally to stretch a piece of pantyhose material in front of the lens. Close-up and split diopter lenses. While these are not technically filters but accessory lenses, they are sold by filter manufacturers as part of their product lines, using the same holders and attachment systems. A close-up lens is a single or two-element converging lens used for close-up and macro photography, and works in the same way as spectacles used for reading. The insertion of a converging lens in front of the taking lens reduces the focal length of the combination. Close-up lenses are usually specified by their optical power, the reciprocal of the focal length in meters. Several close-up lenses may be used in combination. The optical power of the combination is the sum of the optical powers of the component lenses. A set of lenses of +1, +2, and +4 diopters can be combined to provide a range from +1 to +7 in steps of 1. A split diopter has just a semicircular half of a close-up lens and a normal filter holder. It can be used to photograph a close object and a much more distant background, with everything in sharp focus. With any non-split lens the depth of field would be far too shallow. Materials and construction. Photo filters are commonly made from glass, resin plastic similar to those used for eyeglasses, polyester and polycarbonate. Sometimes acetate is used. Historically, filters were often made from gelatin, and color gels. While some filters are still described as gelatin or gel filters, they are no longer actually made from gelatin but from one of the plastics mentioned above. Sometimes the filter is dyed in the mass, in other cases the filter is a thin sheet of material sandwiched between two pieces of clear glass or plastic. Certain kinds of filters use other materials inside a glass sandwich. For example, polarizers often use various special films, netting filters have nylon netting, and so forth. The rings on screw-on filters are often made of aluminum, though in more expensive filters brass is used. Aluminum filter rings are much lighter in weight, but can bind to the aluminum lens threads they are screwed into, requiring the use of a filter wrench to get the filter off of the lens. Aluminum also dents or deforms more easily. High-quality filters are multi-coated, with multiple layer optical coatings to reduce reflections. Uncoated filters can reflect up to 12% of the light, single-coated filter can reduce this considerably, and multi-coated filters can allow up to 99.8% of the light to pass through. The loss of light is not important, but part of the light is reflected inside the camera, producing flare and reducing the contrast of the image. Manufacturers brand their high-end multi-coated filters with different labels, for example, B+W, MRC, MRC Nano, Hoya, HMC, HD, Heliopen, SPMC. Filter sizes and mountings. Manufacturers of lenses and filters have standardized on several different sets of sizes over the years. Threaded round filters. The most common standard filter sizes for circular filters include 30.5 ohm, 37 ohm, 40.5 ohm, 43 ohm, 46 ohm, 49 ohm, 52 ohm, 55 ohm, 58 ohm, 62 ohm, 67 ohm, 72 ohm, 77 ohm, 82 ohm, 86 ohm, 95 ohm, 112 ohm and 127 ohm. Other filter sizes within this range may be hard to find since the filter size may be non-standard or may be rarely used on camera lenses. The specified diameter of the filter in millimeters indicates the diameter of the male threads on the filter housing. The thread pitch is 0.5 ohm, 0.75 ohm or 1.0 ohm, depending on the ring size. A few sizes come in more than one pitch. Filter diameter for a particular lens is commonly identified on the lens face by the mathematical symbol or euro. For example, a lens marking may indicate a euro OI 55 euros ma euro. Square filters. For square filters, 2 inches a, 2, 3 a, 3, and 4 a, 4 were historically very common and are still made by some manufacturers. 100 ohm a, 100 ohm is very close to 4 inches a, 4, allowing use of many of the same holders, and is one of the more popular sizes currently in use. It is virtually a standard in the motion picture industry. 75 ohm x 75 ohm is very close to 3 inches a, 3, and while less common today, was much in vogue in the 1990s. The French manufacturer Coquin makes a wide range of filters and holders in 3 sizes which is collectively known as the Coquin system. A size is 67 ohm wide, a Euro OE par Euro size is 84 ohm wide, and a Euro OE X Pro Euro is 130 ohm wide. Many other manufacturers make filters to fit Coquin holders. Coquin also makes a filter holder for 100 ohm filters, which they call the A Euro OE ZAR Euro size. Most of Coquin's filters are made of optical resins such as CR39. A few round filter elements may be attached to the square rectangular filter holders, usually polarizers and gradient filters which both need to be rotated and are more expensive to manufacture. Coquin formerly had competition from Hoya's Horex system and also a range made by Ambico, but both have withdrawn from the market. A smaller Euro UA Sistema Euro range is still made by Format-Hitech. In general, square filters from one system could be used in another Sistema Euro unregistered trademark S holders if the size was correct, but each made a different system of filter holder which could not be used together. Lee, Tiffin, Format-Hitech and Stingray also make square/rectangular filters in the 100 A, 100 and Coquin a Euro OE par Euro sizes. Gel filters are very common in square form, rarely being used in circular form. These are thin flexible sheets of gelatin or plastic which must be held in rigid frames to prevent them from sagging. Gels are made not only for use as photo filters, but also in a wide range of colors for use in lighting applications, particularly for theatrical lighting. Gel holders are available from all of the Square Euro UA Sistema Euro makers, but are additionally provided by many camera manufacturers, by manufacturers of gel filters, and by makers of expensive professional camera accessories, particularly those manufacturers which target the movie and television camera markets. Square filter systems often have lens shades available to attach to the filter holders. Rectangular filters. Graduated filters of a given width are often made oblong, rather than square, in order to allow the position of the gradation to be moved up or down in the picture. This allows, for example, the red part of a sunset filter to be placed at the horizon. These are used with the system holders described above. Bayonet round filters. Certain manufacturers, most notably Rollet and Hasselblad, have created their own systems of bayonet mount for filters. Each design comes in several sizes, such as Bay I through Bay 8 for Rollet, and Bay 50 through Bay 104 for Hasselblad. Series filters. Starting in the 1930s, filters were also made in a sizing system known as a series mount. The filters themselves were round pieces of glass with no threads. Very early filters had no rims around the glass, but the more common later production filters had the glass mounted in metal rims. To mount the filters on a camera, the filter was placed between two rings. The mount ring either screwed into the lens threads or was slipped over the lens barrel, and the retaining ring screws into the mounting ring to hold the filter in place. The series designations are generally written as Roman numerals, I to 9, though there are a few sizes not written that way, such as Series 4.5 and Series 5.5. Most series filter sizes are now obsolete, production having ceased by the late 1970s. However, Series 9 became a standard of the motion picture industry, and Series 9 filters are still produced and sold today, particularly for professional motion picture cinematography. See also, color gel, optical filter, list of photographic equipment makers, references. External links, photography filters, UV filters test, description of the results in summary, lenstip.com, polarising filters test, results and summary, lenstip.com, analysis of camera filters biz.